Have you ever struggled with rigging stylized character, countless hours of weight painting, weird deformation and not knowing what to do? I've got something just for you. In this tutorial, we are going to learn how to create an interactive alpha mask that gives us a freedom when placing the lips of our character. No complicated modeling, no advanced rigging. So let's get started. First of all, let's get rid of everything in the scene and prepare a simplified setup to show you the basic principle behind this setup. By the way, I'm using Blender 501. So let's create the UV sphere and the circle. Let's select the circle and enter the edit mode. Let's press A to select all vertices, then press F to fill the surface. After that, we can exit the edit mode and enable smooth shading for both objects. We can also add a subdivision modifier. It will help us later. Now we want to create a setup that measures the distance between those two objects and store it as a mask attribute. Okay, so let's now open the new window and open the GeoNodes tab. Now let's select the UV sphere and press New under the GeoNodes tab. We have two nodes here. And to make these two surfaces interact with each other, we also need to bring the circle object into this setup and set the object info node to relative. Okay, so now let's add a named attribute node. Leave it set to float and type mask in the name field. Let's add a sample nearest surface node and set it to vector because the position attribute is a vector in 3D space. This node basically finds values at the closest points on the surface of the source mesh geometry. Let's plug the geometry output from this node into the mesh input here. Then let's create a position node and plug it into the value input and sample position input. The position node outputs the vector that indicates the location of each element of the geometry. Value input is the field we want to evaluate on the source geometry for the transfer, and sample position input is the starting position for finding the closest point on the target mesh. The next nodes to create are the capture attribute node and the set position node. Let's plug the geometry output from the object info node here and the attribute from the named attribute node here. This way we can continue using the circle object with the mask attribute. Now let's plug this output from our circle object into geometry input here and value from sphere object here to position input. Let's create the last two nodes, geometry proximity and store named attribute. The first one calculates the closest point to the target geometry, and the store name attribute node saves the result of the field on a geometry as an attribute with a specified name, which in our case will be mask. Now let's connect everything together. Connect the set position node output to the geometry input here. Connect the position node output to the sample position input. Connect the distance to value. Connect the sphere geometry to the geometry input of this node. Finally, let's make the last connection here. Before we check if everything works, we firstly need to create a material for the sphere that uses the mask attribute for alpha channel. Let's create a new material, then add an attribute node and type mask in the name field. Next, create a color ramp and set it to constant. swap the position of the white and black colors. In my case, the value of 0.01 for the black color worked well, but we can adjust those values later. Then add a mix node and tweak the values as needed. Plug the final result into the alpha channel. Now, to check if the setup works, we have to switch for the render view. But firstly, let's quickly add an HDRI to the scene. Once that's done, you can see that the mask is working. To improve the result further, we can increase the subdivision of the sphere. So that was the basic workflow for creating this interactive mask. Now let's implement it on a character with shape keys that drive the lip movement. Let's create a torus, rotate it and scale it, then move it into position. Enter edit mode and use Alt left click to select the edge loop and press F to fill the empty space inside the torus. This newly created plane will be our surface that drives the mask attribute. Now we can switch the viewport color to random to see everything more clearly. Let's create some basic shape keys for the mouth. For example, smile and mouth wide open. I won't go too deep into explaining shape keys here. If you need a more detailed video about them, let me know in the comments. First, let's create the basic shape key and then add a second one for a smile expression. I will create the smile expression using both edit mode and sculpt mode, and then I will repeat the same process for the mouth wide open shape key. Okay, once our shape keys are done, let's create a basic armature to drive the expressions. We are going to create a main head bone, a jawbone, and a lip bone. The jawbone should be a child of head bone, and the lip bone should be the child of a jawbone. Of course, this is a very simplified setup, just to show you the overall method. The same goes for the shape keys. You will probably want to refine them further and create more, but for now, let's stick to a simple version. Now that we have the basic armature, let's select the sphere, the ellipse, and the armature, press Ctrl P and choose with empty groups. Next, go to the Vertex Group tab, select the sphere and enter Edit mode, pick the head bone, and assign all vertices to this bone group. Then select the ellipse and assign all vertices to the jawbone. Let's select the armature and go to the pose mode to check if everything works so far. Now let's create the drivers for shape keys. Again, if you need a more in-depth tutorial, let me know in the comments. Next, let's go to the shape keys tab, right-click on the first shape key value and choose Add Driver. Set the type to averaged value. For the object, choose the armature. For the bone, select the lip bone, and for location, pick the Z location. Let's repeat the process for the second shape key value. Now let's check if everything works as it should. Okay, now that we have our basic rig, it's time to implement our GeoNode setup we created earlier for this model. First of all, let's go to the edit mode and detach the plane that fills the gap between the lips. It will be our plane for driving the alpha mask. Now let's check if everything still works. Okay, now let's select the sphere and go to the GeoNodes tab. Now we need to add our detached plane to this setup instead of circle object we used earlier. Let's go to the render view and check how it works. As you see, we need to make a detached plane transparent. So let's create a material for it. Finally, change the colors of the meshes so everything is easier to see and test the rig. Then adjust the color ramp to match our case. Okay, so as you can see, everything works properly. One last thing to create is a plane that surrounds the lips. It will be useful in cases where the alpha mask goes beyond the lips shape and helps cover potential issues. Let's create it now. Let's go to the edit mode, Alt left click and the edge loop, then press Shift D to duplicate it, then press P to separate the selection. Now go to the object mode, select the edge loop, switch back to edit mode and extrude it a couple of times. Now what we want to do is find a way to blend this surface with our sphere so it looks like one object in every position. Here's the plan. First, I want to create a vertex groups that will be blended with the sphere object, and then we will use modifiers to help us achieve this effect. So let's go to the edit mode and select the edge vertices. For now, just one loop, and we can adjust it later. Now let's create a new vertex groups and call it something like edge. Next, go to the Modifiers tab and add a Shrink Wrap modifier. Set the method to project, enable both positive and negative. For the target, pick the sphere, and for the vertex groups, select edge. Now we can adjust how the two shapes blend together. Next, what we want to do is add a data transfer modifier. It's not necessary in every case, but it can be very useful for blending surface normals. So now let's add the data transfer modifier. The source object will be sphere and the vertex group will be edge. Next, enable for face corner data, custom normals, and for the mapping, choose nearest corner of nearest face. We can always experiment with different mapping modes to see which works best for our case. I've assigned the same material to the surface as the sphere, then duplicate it and detach the alpha mask, since we only want to use it for the sphere. To blend the surface in a better way, I also moved the data transfer modifier to the last position in the stack. Now let's adjust the surface a bit to improve how the shapes blend together. And here's the result with and without the data transfer modifier. It probably needs more adjustments, but let's leave it as it is for now. Okay, now we should combine both this surface and the ellipse. Now let's check if the setup is not broken, both for the shape keys and surface blending. As we can see, we need to adjust the edge vertex group. In the end, I decided to add more edge loops to achieve a better blend. It always depends on a specific case, so you have to adjust it to your project. As you can see, everything works perfectly. This setup is really simple and fast and gives us the possibility to really speed up the rigging process. No advanced modeling, no complicated rigging methods for the lips are needed. You can also apply this workflow not only for shape keys, but also for the bones. For example, a ellipse mesh with multiple control bones driven through weight painting. If you want to know more about it, let me know. And now, thanks for today, and see you soon.